time to see spanning tree in action. Hey guys, you're welcome to Network Pips. So in our previous video, we discussed about how spanning tree helps to resolve loop on our switch network by blocking one or more ports on our network. He does that by electing the root bridge, and wherever that root bridge is, find the shortest path to get to this root bridge, and the remaining ports we block. So enough of the discussion. Let's see how this thing actually works. So I'm going to use my normal triangular topology to do this. So I'm going to cable up this using just this auto connection cable to do this quickly. So yeah, so if you notice, our port is still showing amber or yellow, yeah, or orange or whatever. I think it's orange or amber. So what this is currently doing now is is on the port transition mode. So it's transiting from blocking, listening, learning, then forwarding mode. So that's what is currently doing now. So let's allow it to finish up, and let's see how this spanning tree works. So it's done. So with what you know now, I can looking at this topology now, I can be able to tell you which of the switch is the spanning tree and the root bridge. You understand? Because I can see that I can see a green label and also an amber link label as well. So I can know that this green label means that this my port is on designated forwarding mode. You understand? So I'm seeing that these two ports are on designated forwarding mode. So automatically this will be the root bridge. Why this other guy is electing root bridge to get root port to get to this root bridge. Why these two guys, you now do election to find out who has the highest MAC address. I do, then I'll block my own. This guy has the highest MAC address between these two, and this guy blocked his own port. But enough of the discussion. Let's really see how it works on the CLI, because that's what we're interested in. So open your CLI. Luckily for us, spanning tree is enabled by default. You don't need to do any configuration to start this guy running. So if we show spanning tree to verify if spanning tree is enabled on your network, that's the command you're going to use. Then you're going to see that spanning tree is showing me spanning tree for VLAN 1. So the first information I'm seeing here is the information of the switch that won the election, the bridge ID of the switch that won the election. So I'm seeing the root ID and also the priority of that switch, then the MAC address of that switch, then also the cost, then the port which he's neighbor with that switch on, then also showing the hello timer. I'll be sending this. He'll be sending his BPDU hello timer every 2 seconds. Then also he has an age timer of 20 seconds, which is if I didn't hear from this switch in the next 20 seconds. After the 20 seconds, I'm going to assume that he's no longer the root bridge, then find a new master. Then the delay forwarding time is going to take to transit to forwarding mode. Then also we have the bridge ID. The bridge ID is the information of the switch of this local switch. You can see that's information of this local switch. So let's compare it with the switch that became the root bridge. So you are reading from left to right. So from here to like this. So looking at this guy 00, then 4, you can see 4 is slower than 6. So that's why this guy won the election. So another way I can see that this guy is not the root bridge is that I can see on the interfaces that S0/1, which is on root port, the port going to the root bridge, while the F0/2 is the designated port connected to the other switch as well. You can see the cost of each port is 19, so I can know that this is a fast Ethernet port as well. So let's check this other switch as well, this guy, and let's see what's happening there. So I'm going to enter enable config T. Going too far. Use Control Shift 6 to exit from this translating system. Then show spanning tree. You can see information of the root bridge as well, which is showing this guy is not the root bridge. Why the bridge ID, the information of the bridge I'm currently on now. Let's compare the MAC address, because by default the priority will be the same. You can see this guy is also lower than him as well. look at the interface state as well. You can see, and the root, you can see that this guy is clearly showing me that this has a root port, forwarding, alternate port, and also state is blocked. So alternate port, which means that it can still switch to forwarding before designated if the topology changes. You understand? So this is clearly showing that this is not a root bridge, because a root bridge will not block this port, of course, and it will not have a root port as well. I'm going to come out from here and go to this guy, then come here to this last switch, then enter show spanning tree. Then you can see the first information I'm seeing here is that this is the root, so which is telling me this is the root bridge. You notice I didn't see this other information in all those other switches. Then you notice the MAC address and the MAC address of these two is the same. Then look at the state of the ports, they are all the same. You can see. So this is how you can find out, verify your spanning tree and know if it's enabled and which switch is the root bridge on your network as well. So let's do something. Let me quickly set up VLANs on these switches and the multiple VLANs on these switches. I'm going to do just VLAN 10. Then do the same thing for this other one. Enter the configuration mode VLAN 10. Then go to this other one. Enter configuration mode VLAN 10. Then let's show spanning tree again. I'm supposed to see multiple spanning tree instance now. So spanning tree. Okay, I'm still seeing one. Okay, you know the problem. So you can guess, once you have multiple VLAN on your network, remember your switch by default is going to be on auto. So their operational mode is going to be on administrative, it's going to be on access port mode, and access conveys only one VLAN. So we are meant to put these switches on trunk mode to enable them convey multiple VLAN. So it's conveying only VLAN 1 at the moment. So I want it to convey VLAN 10. So this information, so they can be able to exchange this information together. I'm going to enter interface F0/. So I'm going to do this non-arrange. So I will automatically trunk this interface and trunk this interface. And remember, if I turn this interface, see this guy is on auto, this guy was automatically become trunk as well. So I'm going to do interface range F0/1 to 2 switch ports mode trunk. So you can see this other one. I don't need to come here and trunk this one, The only thing I need to do is come to this switch now and trunk this other interface, and this one automatically trunk as well. I'm going to come here. What's that interface again? Interface F0/2, right? Yeah. Global configuration mode. What am I doing? Yeah. Interface F0/2 switch port. Switch port mode trunk. So I just trunk that interface again of this one. So currently it's now conveying multiple VLANs along these guys. So let's go back to this okay, let's allow it to come up and let's see. Let's allow the topology change to finish up. Or let me just go to this other switch that was the root bridge and the show, okay, spanning tree again. So if you notice, now I'm not having multiple VLAN instance now. I have VLAN 1 and also over here now I have VLAN 10 for this guy. But notice one thing that is wrong now. This switch is the root bridge for all the VLAN configured on our network. VLAN 10 and VLAN 1 and VLAN 10, which means even if I have other VLANs now, 20, 50, all those kind of stuff, this switch will still become the root bridge. And we don't want that to happen, because of we want to load balance and load balance traffic among our switches. Some traffic will go here, some traffic will go here, some traffic will go here. I want to make this guy the root bridge for VLAN 10. So I'm going to come here now. To do that, I'm going to go to global configuration mode, then spanning tree, then question mark. I'm going to do mode. So I think it's good time to talk about this now. So they have different types of spanning tree mode. They have the common spanning tree mode, which is the industry standard. This is the first spanning tree mode that we have. Understand? Industry standard is going to be running on every other switches, and this is the default of all on all at least Cisco older switch of Cisco. Understand? Then you have another spanning tree, pavilion spanning tree protocol Cisco developed, which is Cisco proprietary. You understand? Which is this one, pavilion spanning tree protocol, which will be the one Cisco will be running on by default. I mean to say, all their switches will be running this pavilion spanning tree protocol. Understand? Which is equivalent to this common spanning tree protocol (STP). Then we also have another one, rapid spanning tree protocol. Rapid spanning tree protocol is another industry standard, 802.1W, understand, standard, which it can run on any switch regardless of the vendor. Switch Cisco, you know that Cisco love showing themselves. Cisco developed another one after that one, which is called rapid pavilion spanning tree protocol, which is this one as well, which is the same thing as it works the same way as the normal rapid spanning tree protocol. Why after that one, Cisco what do they call it? They now developed another one, multiple spanning tree protocol again, which all these ones are beyond the scope of this work, which we discuss on the CCNP level. So for now, I don't need to set the mode because the mode is by default on the pavilion spanning tree protocol. The difference between these spanning tree protocol modes is just the conversion time. So the rapid, of course, on the name is going to have a higher conversion time than the normal spanning tree protocol. I'm going to do spanning tree protocol. I'm going to do VLAN. So for which VLAN do I want to make this switch the root bridge? I want to make this switch the root bridge on VLAN. So 10. So that was showing me. Then I have two options here. Either to do root primary, you understand, then this switch automatically become the root bridge. So it's going to decrement my value. It's going to decrement this priority. You understand? It's going to decrement this priority. But if you don't want to use that because you don't know which other switch that has a lower priority than this guy, I can come here and manually configure this priority like this. Priority, you can see, is going to be an increment of 496 and also a decrement of 496. So I can either do let me just type any number. It's going to show me a sample of number I'm going to use. I'm going to use let me say my current one is on 30,767. So it's on this guy, 32,000. So it's on this guy. So I'm going to decrement it to this guy. I'm going to decrement it to this guy. So or this guy, for example, I'm going to decrement it to this guy. Copy, then come here and paste it. So for it decremented it to this guy. So I'm going to go back now, show spanning tree protocol. You can see for that VLAN 10 now, this is the root bridge. You understand? So it's showing me the root bridge now. It's no longer that my previous switch now. It's no longer this switch that is the root bridge for VLAN 10. It's now showing me that this guy is the root bridge for VLAN 10. So that's it. You understand? So then you can see the topology have already changed. You are no longer seeing that amber color, but internally is blocking some ports. So if we come here now for this VLAN 10, now you can see that on VLAN 1 is blocking his ports. You understand? Why on VLAN 10 all his ports are on 4 designated. You can see. So but if I go to that switch that was root bridge before, which is this guy, right? Let me expand it and show his spanning tree again. Show spanning tree. You can see on VLAN 1 he's still the root bridge, but gone down to VLAN 10 now. It is editing the port going to the root bridge. And it's not the root bridge for VLAN 10. It's showing me the suite that is root bridge for VLAN 10, which is the other guy. Regardless of the priority, I've already manually tweaked it. So if you notice, if we plug our system to this switch now, understand, it's going to take you approximately, let me say, 50 seconds for this thing to come up. Understand? So imagine your user, they came to work maybe by 8, they plug their system, they have to wait for like 50 seconds to start sending mail. Man, they're going to buzz you, or like, in fact, 2 seconds now is like 20 minutes, like 2 hours. People don't like waiting that long to not having access to internet. Understand? So 50 seconds, you can see as I'm even talking, it's still converging. Understand? So like, how are we going to speed up this uptime of this port, at least to our end devices that are connected? So we are going to use what they call a port fast to do this. So port fast enables us to increase the spanning tree uptime of our access ports. So it does not disable spanning tree on that port, rather it increases the uptime, the time it's going to take for that port to come up. So to do that, I'm going to go to that port, which is F0/3, right? That this PC is connected to F0/3. I'm going to go to that port, then interface F0/3, switch for spanning tree ports fast. Then that's all. So it's going to give you a warning, a sound warning that the port fast should not be enabled between switches and bridges and so on. That is going to result to a temporal loop on your network. So you can see port fast is already enabled. So if I unplug this cable now and plug it back to that F0/3, notice how fast the thing came up. It didn't transit to that F0/ to that blocking, forwarding, and all those kind of stuff. But if I plug it to any other port now, for example F0/4, you can notice that is taking time again because port fast is not enabled on that port. But so what if we have like up to 50 devices on our network? Are we going to go to each and every one of those devices one by one to start configuring port fast? No. So we're going to enable this configuration on our global configuration mode, to enable it, to allow it to be any end device that connects to our access port is going to automatically enable port fast on that port. So to do that, we're going to do spanning tree port fast, then default. That's the command. So spanning tree port fast default will enable port fast automatically on all the access ports. So even if I unplug this guy and plug it to this access, to this F0/4 again, it's going to come up. Or whichever port I plug it again, so far it's an access port, and default you can see it's coming up. You understand? Yeah. So I'm going to negate that command because I want to do other things now, another thing now. So I'm going to remove that command. So where is it? No, I'm going to remove that command. Don't want it to be there again. So I'm going to verify if it's still there. Okay, I've removed it. So, but remember, it's still on this guy. So, but if you want to remove spanning tree on this interface mode now, on the interface mode, let me say F0/3, you don't do no spanning tree. You're going to use spanning tree port fast. Remember, disable. That's what you are going to use. If you want to disable it on the interface level, you're not going to do no spanning tree port fast. No, you're going to use spanning tree disable to do that. So yeah. So let's see how we can secure our switch more often. So in our environment, some of our users might tend to bring in rogue devices or rogue switches on our network. Some are even running some VMs, some virtual machine hosting switches on their systems. some of all these maybe people that are newly into networking, CCNA, they are learning all these things, or CCMP, they plug a switch on our network. This, with that switch, it might, they will make their switch the root bridge and forward all traffic to their own switch, and all the traffic on our network will be forwarded to their own. Let me show you how this thing really works. So I'm going to remove, I'm going to bring up another switch now and show you what will happen now. So I'm going to bring up another switch, drop it here. I'm not going to plug that switch yet. I'm going to make sure that switch is coming up. Okay, stop. Then enter config T, then spanning tree VLAN 1 and 10. Then let me make it priority. The lowest priority is 0. So I'm going to make sure that this switch is the root bridge for all the VLAN on our network, both VLAN 1 and VLAN 10. You understand? So the least bridge, the least priority on our network is going to be 0, 0, and no switch has the lowest priority on this network than this guy. Now, so if I plug this guy on my network, guess what will happen? Just relax and see what will happen. So going to start transiting to forwarding, blocking, listening, forwarding, blocking, listening, learning, then forwarding state. They will eventually find out that this switch is the root bridge. So imagine a user connecting to this switch. Understand? Okay, it's up. Let's see which switch is the root bridge of this guy. Remember, this guy was the root bridge for VLAN 1, right? So show spanning 3. Where is that root bridge here? So look at the root bridge for VLAN 1 and 10. Are you seeing that? So if I go here also on this guy as well, let me see. This guy was the root bridge for VLAN 10, right? Let me expand this. Even on VLAN 10, this guy is not. Is it the root bridge? Okay, remember, there is no. I didn't create any VLAN 10 on this guy. So let me quickly create that VLAN. Drop that interface. F0/1 switch port move trunk. Then exit. Then VLAN 10. So it's going to, I didn't trunk that interface, so it's going to do the recalculation again, and let's see. I didn't trunk this interface initial time. I didn't configure VLAN 10 here. So let's see what will happen if this guy is still going to become the root bridge for VLAN 10, or is it going to switch to this guy? If this guy is going to take it all. Is he up? Show VLAN, show spanning tree. So you can see this is the root bridge for VLAN 1 and also for VLAN 10. I told you so. So it's up now. So if I go back to this switch now, and do show VLAN, you see on VLAN 10, he's no longer the root bridge for VLAN 10 as well as this guy over here. He won't be the root bridge for VLAN 10. So you can imagine someone brought in a switch that has an old modern switch that has a lower MAC address, because the older the switch, the lower the MAC address. You understand? That has a lower MAC address than our newly fast switches. You understand? And plug it on our network, it is going to automatically become the root bridge, because maybe by default our priorities are the same. We might not even get to change the priority. We just plug it cable this guy together, and this guy come here and plug in that old modern switch and on our network, and he will automatically become the root bridge on our network, and packet will first of all flow to this guy like this. Let me say this, there is a device connected here as well, and this guy wants to communicate to that device. Packet will first of all flow to this guy first before going to this guy. So this guy will receive that your packet. Maybe he configured a span port here that will be learning, capturing your traffic and open up a Wireshark or any packet sniffing tool and be capturing your data on plain text. So how are we going to block this? We're going to configure what they call a BPDU guard. So any what BPDU guard does is that it's not going to allow switches to be plugged on our access port. So any port that is on our access port that is for our whole maybe PCs or another kind of thing, if you plug a switch on that port, it's going to automatically shut down that port for us, just like our port security. So how are we going to do that? Let's see. So let me say on this guy F0/4, right? That's where he's being plugged in. I'm going to come to F0/4, interface F0/4, then spanning tree BPDU, that's it, the first one, enable. If you want to disable it, you don't use no BPDU guide, use disable as well. So spanning tree BPDU guide, enable, and watch what will happen. Already he just put that port on a shutdown mode immediately, like he didn't even waste time because he just found the switch. Oh, this guy is there. So you can see it's already shut down that port immediately for me, and this guy cannot come up again. So let's see the state that port is on now. If I show IP interface brief, that's F0/4, you can see that port is down. It's down. It can't come up. It can't come up. If I go into more details into that port, show interface F0/4, it's going to show me that port line protocol is down. That port is down. Line protocol is down. It's on error disable mode. Now remember, we have seen this error disable mode before on port security, and the way we can bring up this error disable mode port is by administratively shutting down that port and bringing that down port back up again. So for us to bring out that port again, I'm going to disconnect this cable because the switch is still connected there. Again, I'm going to disconnect this guy and bring up that port. So because even if I come to that port now, even if I go to that port now, F0/4, and do no shutdown, that port is still going to become down. It's not going to come up. Do show IP interface brief, you can see it's still going to be down. You understand? Still going to be down. Even if I do show interface F0/4, you can see it's still on error disable mode. You understand? So how am I going to bring it up? I'm going to shut it down. Then it's going to go administratively down. You do show IP interface brief. It's going to be on administratively down. Then you now bring it up with the command no shutdown to negate that no shutdown command. Then it's going to come up. You understand? So do show IP interface brief. You understand? That port is now up. You understand? It's up now. If I do show IP do show interface F0/4, you can see it's no longer error disabled, rather it's disabled because there is nothing plugged to that port. For me to verify now, I can quickly plug in this my PC there and it will come up. So it's not blocked anymore. It's not being shut down. So that's what's, yeah, it's going to transit for like 50 seconds and come up again, and for us to just see it's up and it's not blocked anymore. Okay. So it's even showing up already. If I come here, do show IP interface brief, you can see F0/4. See, it's up. Then show interface, you can see connected. You understand? So that's about it for this course spanning tree. I would like to thank you for watching and see you in the next video. Please don't forget to subscribe to my channel and click the like button, I say button, like button, and feel free to share this video to get more people to benefit from this channel. Thank you.